24 kilogram brick is dropped from a height of 3.4 meters onto a small nail, which gets pushed further into the ground by 1.5 centimeters. Assuming all the potential energy gets converted into driving into the nail, find the maximum force acting on the nail. So, let's draw a diagram. So here's our nail, little tease, and we have a brick. The height of the brick is 3.4 meters. H equals 3.4 meters. And this drives a small displacement d of 1.5 centimeters. So I'm going to take my reference level. So 3.4 meters is the height. So the potential energy of, assuming this is the relative position, so height 0, the potential energy is 0 relative to this position. Where the nail is, the brick has a potential energy of mgh. All that energy just before it hits the nail gets converted into kinetic energy, so it's accelerating faster and faster and faster. Its kinetic energy gets translated into 1/2 mv squared, but that 1/2 kinetic energy gets converted into a displacement, causes a force being applied on the nail at distance d. So we know that the total energy is also equal to force times distance. So we're asked to find F. We know h and d and everything. So we can solve for F is equal to mgh over the distance that the nail is pushed into the ground. So the mass of the, actually what is the mass? 24 kilograms. 24 kilograms, so we'll have 24 kilograms times 9.8 meters per second squared for gravitational acceleration at a height of 3.4 meters. So you might say it's 1.5. Remember, 1.5 centimeters is negligible compared to 3.4 meters. So it's very negligible. So this is errors of plus or minus 0.1 meters, which is effectively plus or minus 0.5 centimeters. So this is within the precision. So we don't have to worry about whether the height is the ground or to the nail head, which is 1.5 centimeters higher. So the height is 3.4 and the distance is 1.5 centimeters, but it's not in standard units, so 1.5 centi is 10 to the minus 2, so it's 1.5 times 10 to the minus 2 standard units. So we get a value of, where's the calculator? Oh, here we go. 24 multiplied by 9.8 multiplied by 3.4 divisible by 1.5 exponent to the 2 negative. We get 55.3 times 10 to the 4 newtons. So the applied force, effectively, the maximum applied force on the nail could be at most 5.3 times 10 to the 4, assuming all the potential energy on the top was translated into driving the nail into the wood or into the floor.